going to be going over Chapter 2, Quiz 2 for corrections. Just a reminder on corrections, you must write the problem out one time, the way exactly how it looks on your paper. For the figures down here, just kind of sketch a picture. I'm not going to be super picky about how it looks, but I do need to see something that resembles that. But you must write down the original problem one time onto your paper. After that, underneath it, you need to do the work 3 times and the answer 3 times. So work and answer, work and answer, work and answer. Okay? And use this information for exercises 1 through 3. A figure has coordinates A, 0, 2, B, 5, 5, and C, 5, 2. And then K equals 2. K is your scale factor. So since your scale factor is 2 and it's larger than 1, we know that this is going to be an enlargement. But we're going to use that information to solve numbers 1, 2, and 3. Number 1 says write an algebraic representation for the dilation. Algebraic representation, algebra is just numbers and letters combined. You want to make a rule to follow to represent what happens when your scale factor is 2. Well, in ordered pairs, we always start with x, y, and then we apply our scale factor. Scale factor means to multiply. Factor means multiply. So we're going to multiply each of those parts by 2. So that means I'm going to say 2x for 2 times x, and then 2y for 2 times y. And that is your final answer for number 1. Number 2 says, determine the coordinates of the vertices of the figure after a dilation with a scale factor k equals 2. So what we do for number 2 is we create a table. You must draw this table 3 times. And then you must answer it 3 times to get your corrections. Okay? We always start with our original points. Then we're going to apply the rule 2x, 2y, and then we have our new points. Well, straight from the problem, we found that A is 0, 2, B is 5, 5, and C is 5, 2. So I'm just going to write that down. A is 0, 2. B is 5, 5. And C is 5, 2. Now that I multiply a 2 onto each of those, it becomes 2 times 0, 2 times 2, 2 times 5, 2 times 5, and then 2 times 5, 2 times 2. All we have done is combine this column here of our column of 2 times x, 2 times y, that rule, we've applied that column to this row. So if 2 times x, for A, x was 0, so it's 2 times 0. For the point A, y was 2, so 2 times y would be 2 times 2. 5 and 5 would be 2 times 5 and 2 times 5. 2 times 5, 2 times 2. Just kind of blends those together, combining that rule down with the points going across. So now, if my first point was A, this point is now A prime. 2 times 0 is 0, and 2 times 2 is 4. If this was point B, then this is point B prime. 2 times 5 is 10. 2 times 5 is 10. 2 times, and then if this was point C, this is point C prime. 2 times 5 is 10, and 2 times 2 is 4. So that's just simply solving the math here to create our new points. Once you've done that, you need to just write out your answer. A prime is 0, 4. B prime is 10, 10. And C prime is 10, 4. Work, answer, 3 times each. Number 3 says, graph the original image and the dilation on the coordinate grid at the right. Be sure you label your points correctly. Okay? So your original points should be written and labeled A, B, C. And then your new shape should be plotted and should be written as A prime, B prime, C prime. So let's go ahead. Let's go ahead and get my original shape plotted. 0, 2 means I go to 0 on the x-axis and 2 on the y-axis, so I'm not going over anywhere, but I'm drawing a point right here and I'm calling it point A. 5, 5 means I'm going over to 5 on the x-axis and then up to 5 on the y-axis. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here is my point B. And then C is 5, 2. So over 5, 1, 2, 3, 4, 5, but up to 2 on my y-axis, and there is point C. Then I'm going to connect those points, creating a triangle. That's only the first half. That's the original image. And now we're graphing the dilation. So I'm using those points over there. 0, 4. 1, 2, 3, 4. And I'm labeling it as A prime. 10, 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis. And up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on my y-axis. And that would be point B prime. And then C prime is 10, 4. So you go over to 10, up to 4, and there is C prime, connecting those points together. If you notice, that shape got larger, twice the size of the original, because my scale factor is a 2. When I multiply by anything larger than 1, it gets bigger and is an enlargement. Alright, so this is all the information that you need for numbers 1 through 3. Next, we're going to move on to numbers 4, 5, and 6. Those are done the same way. Make sure that you pay attention to your directions, because a lot of you left off the scale factor. It says for each pair of similar figures, find the scale factor. So you need to tell me what the scale factor is, just like we did in all of our assignments. Then determine the perimeter of the second figure. Round to the nearest tenth if necessary. If it asks you to round to the nearest tenth, that means do not leave it in fraction form. Go ahead and put it in decimal form and round to the nearest tenth, because they want to know in terms of the tenths would be decimals, rounding that way. Be sure you pay attention to the way that your question asks for your answers. So 2 parts to these questions. 1 is the scale factor. 2 is the perimeter. If you remember, when you're looking for the perimeter of a new shape, it's just your perimeter of your original shape times your scale factor. Okay? So we've got to determine the scale factor. And if you remember, your scale factor is equal to your dilation over your original. Also, you know everything about your original. That's what makes it the original. It's what you have everything for. This is where you're starting. Okay? So, for problem number 4, I know that in this first shape, the perimeter is 24, and that side length is 4. Here, I'm looking for the perimeter, and that side length is 5. So, since this is the part that's missing something, that's my dilation. I know everything about my original. So, this is my original, and this is my dilation. Now, I can create a scale factor with the pieces of it that I know about both. I know the side lengths. So, dilation over original means my scale factor, K, is equal to 5 over 4. That's just the ratio of my side lengths that I know on both of those shapes. So my scale factor there is 5/4. That's my first question. Just leave it there as a fraction. We're rounding to the nearest tenth for our perimeter. Okay. The original perimeter was 24, and then I'm going to multiply that by 5/4. I can put that directly into my calculator, and I get that the perimeter is 30. So both of those are my answer for number 4. Make sure that you put K is equal to dilation over original. Make sure that you have labeled your dilation and your original. Then those pieces just kind of fall into place to create your scale factor. The pieces that you know of each of them, that corresponding pieces, those pieces that match up. And then you use the original perimeter from the problem and multiply it by your scale factor. Okay? So number 5. I know everything about my original. So that makes this shape right here my original because I know the side length and I know its perimeter. Here I know a side length, but I do not know its perimeter, so it's my dilation, it's my new shape. So for me to be able to create my scale factor, I'm going to compare the corresponding parts that I know together, and we do dilation over original, so my scale factor is 16 over 12. So K is equal to 16 over 12. I'm going to go ahead and simplify that down to 4/3. Okay. Simplify it down to its least common multiple, but you do not have to turn it into an improper fraction. I mean, you can leave it as an improper fraction. You don't have to turn it into a mixed number because it's much easier to use this way. We also don't turn them into decimals because this is a repeating decimal, and you can't put the repeating decimal into your calculator or multiply by a repeating decimal. So leave your scale factors as a fraction, and then at the very end of your problem, if you need to round, that's where you round because it makes your problem more precise. Okay, so my original perimeter was 40. I'm going to multiply it by my scale factor of 4/3. And when I do, I get 53.3 repeating. But since it says round to the nearest tenth, if I have 53.33 and the 3 is going on, I look at this 3. It tells me to stay. Okay, so I don't need to round up. So my answer is 53.3. And lastly, we're going to do the same thing with number 6. I know everything about my original. So that makes this my original because I know its side length and its perimeter. This is my dilation. Just looking, I've gotten smaller, so I know my scale factor should be a fraction that is less than 1. That's a good mental check to make sure your sizes are going down. So for number 6, K is equal to dilation over original, so I'm comparing those corresponding parts. I have 3/5. So my dilation here, my scale factor is 3/5. If my original perimeter was 27, I'm going to say 27 times 3/5. And when I plug that into my calculator, I get 16.2. And I don't have to round because it's already left in the 10th place for me. All right, so that's how you do 4, 5, and 6. 7 and 8 are similar. It's just a word problem, so you kind of have to piece some stuff together. So let's take a look at that. Another thing on 7 and 8 is there are no pictures. So just like I always say, when in doubt, draw it out. Go ahead and sketch out what this looks like. So that way you kind of have a good idea, a good feeling about what's going on. An artist's drawing is 8 inches by 10 inches. So we have a drawing here. 8 inches by 10 inches. Okay, we're going to use that information for 7 and 8. It says the artist reduces the drawing, making it smaller, to make the prints that are 0.6 times the size of the original image. So that means my scale factor is 0.6 or 6/10. What will the perimeter and the area of the prints be? Okay, so I need to know the original perimeter and I need to know the original area. Well, for me to find perimeter, we just add up all the sides. So that's 8 plus 10 plus 8 plus 10. And when you do that, you get 36. You're more than welcome to use the 2 times 8 plus 10 or 2 times 8 plus 2 times 10. Any of those formulas for perimeter if you like. I usually stick to just adding up all the sides because the formulas only work for rectangles. When you want to find perimeter of triangles and other irregular shapes, you just add up all the sides. So for the most part this year, anytime we do perimeter, I'm just going to add up all the sides. But you can choose to use those formulas when they fit in a situation like this. And then the area, we do length times width, so that's 8 times 10, which is 80. So that's some prior knowledge, some prior information that I needed based off of my instructions. Now, for me to find perimeter, I just take my original perimeter of 36 and multiply it times my scale factor. And I get 21.6, and we're talking about inches, so I'm going to go ahead and label that as inches. Now, the difference between perimeter and area, so far we've only done perimeter. Well, when we do area, instead of multiplying by the scale factor, we have to multiply by the scale factor squared. So I'm going to take my original area of 80, okay? We used perimeter for the perimeter, we used the area for the area. Multiply it times your scale factor. And then we need to make sure that we square our scale factor. Remember, if your scale factor is a fraction, to always keep that fraction inside of parentheses so the square knows to square both parts of that. But since it's a decimal, it doesn't matter if you put it in parentheses or not. But I will tell you that it never hurts to put it in parentheses. So if you're not sure, or it's always a good habit to get into just going ahead and placing that inside of parentheses. And when I multiply that together, I get 28.8 inches. And since we're talking about area, it's inches squared. Okay, so that was number 7. I expect to see all of this work 3 times each, and these answers 3 times each for you to get credit. Number 8 says, suppose she wants to enlarge the drawing to make a poster that is 28 inches by 35 inches. Okay, so let me go ahead and erase this. Give y'all just one more second to get any of that copied down. And then number 8 says, suppose she wants to make a poster that is 28 by 35. So instead of her scale factor being 0.6, that was for the last problem, we are now creating a 28 by 35 print. Remember, earlier we said that the scale factor is equal to the dilation over the original. So if this is an 8 by 10, 8 corresponds with 28, and 10 corresponds with 35. So my dilation, this is my new shape, we would say the 28 corresponds with the 8. And when I simplify that, I get 7 over 2, or 3.5. I'll take either one of those as an answer.